We are given f of x and g of x and asked to determine and simplify f of x plus g of x, which means we need to add these two rational expressions. Notice how we do not have a common denominator, and therefore the next step is going to be to factor the denominators so that we can determine the least common denominator. But notice how here the denominator of 2x plus 7 does not factor. And now for the denominator of 2x squared plus 9x plus 7, the only common factor among all three terms is 1, and therefore if this does factor, it will factor into two binomial factors. Because the first term is 2x squared, which is equal to 2x times x. We have a 2x and an x. We have a 2x and an x in the first positions of the binomial factors. And then because the leading coefficient is not 1, it's 2, we now place the factors of 7 in the second positions so that the sum of the inner and outer product is equal to positive 9x. Because the sum must be positive, we will use the positive factors of 7, which are 1 and 7. Let's try placing a plus 7 with the 2x and a plus 1 with the x. And now check the sum of the inner product and outer product. The inner product is 7x plus the outer product is 2x, which does give us 9x, the middle term. We now know this is factored correctly. Now looking at the factors of the denominators, we should be able to recognize that the least common denominator is going to be the product of these two binomial factors, and because this rational expression does not have a factor of x plus 1 in the denominator, we multiply the numerator and denominator by x plus 1 to create an equivalent fraction with the denominator of the quantity 2x plus 7 times the quantity x plus 1. Now that we have a common denominator, we can add the rational expressions. The denominator remains the same, and the numerator is now 2x times the quantity x plus 1 plus the quantity 11x plus 21. We now need to simplify the numerator, which means we will distribute 2x here and then combine like terms. 2x times x is 2x squared, and we have plus 2x times 1 is 2x, then we have plus 11x plus 21. Now we combine like terms. 2x plus 11x is 13x, and therefore the numerator is 2x squared plus 13x plus 21. We're not done yet though. We now need to factor the numerator and see if there are any common factors between the numerator and denominator that will simplify out. The only common factor among all three terms is 1, and therefore if the numerator does factor, it will factor into two binomial factors. Because the first term is 2x squared, which is equal to 2x times x. Let's place a 2x here and an x here. Again, because the leading coefficient is not 1, it's 2, we now need to place the factors of positive 21 into the second positions so that the sum of the inner product and outer product is equal to positive 13x. Let's use the factors of 3 and 7 for 21. Let's try placing the plus 7 here and the plus 3 here. And now check the sum of the inner product and the outer product. The inner product is 7x, plus the outer product is 6x, and 7x plus 6x is 13x, and therefore this is factored correctly. And now notice we do have a common factor of 2x plus 7 between the numerator and denominator, and therefore this does simplify. 2x plus 7 divided by 2x plus 7 simplifies to 1, and therefore the simplified sum function is the quantity x plus 3 divided by the quantity x plus 1. For the second part of this question, they ask us for the values of x that must be excluded from the domain of the sum function. We must exclude the values of x that make the denominator equal to 0 because division by 0 is undefined. But it is important that we use the sum function before we simplified it to determine the excluded values, which means we will use this form of the sum function to determine the excluded values. Let's do this on the next slide. Again, before we simplify out the common factor of 2x plus 7, we will now determine the values of x that make the denominator equal to 0, because we must exclude these values because division by 0 is undefined. Which means we need to find the solutions of the quantity 2x plus 7 times the quantity x plus 1 equals 0. This product is equal to 0 when 2x plus 7 is equal to 0 or when x plus 1 is equal to 0. And now we solve for x. Here we subtract 7 and divide by 2, which gives us x equals negative 7 halves. Solving for x here, we subtract 1 on both sides, and we have x equals negative 1. So these are the two excluded values from the domain of the sum function, because if x is negative 7 halves or x equals negative 1, we would have division by 0, which is undefined. And we list those values here. Also, if we go back up to the original functions, notice f of x would have a denominator of 0 when x is equal to negative 7 halves, which is another reason why negative 7 halves must be excluded. And we also now know the factored form of the denominator of g of x is the quantity 2x plus 7 times the quantity x plus 1. Notice both of these excluded values would make the denominator of g of x 0, once again giving us division by 0, which is undefined. I hope you found this helpful.